Okay. This is May June 062542 IGCSE Physics May June 21. Um, Figure 7.1 shows two magnets and the gap between the N pole of one magnet and the S pole of the other magnet. On Figure 7.1, draw three lines to show the pattern direction of the magnetic field in the gap. Obviously, our magnetic field will be going from north to south. So they said in the gap. Okay, so don't be doing this. No, we said in the gap. Okay, so we're gonna do this. It goes one straight from north to south. If you have a ruler in the exam, it would help. One like this and one like this. Let's check the answer. Three lines from N to S face. The middle line must be straight and perpendicular to the end faces. At least one arrow from N to S, no arrows from S to N. Okay, so that's the 2 marks. Again, this one has to be straight. Like you need a ruler for this. I'm gonna try my best to make it straight, and it also has to be perpendicular. Oh, that ain't straight. But please make it straight. Oh, no, no, wait, wait, wait. I'm not gonna let it go like this. Hold up. That's straight, somewhat straight. Okay. Uh, Figure 7.2 is a repeat of Figure 7.1 showing the two magnets. On Figure 7.2, draw the position of a plotting compass needle when it comes to rest in the gap between the N pole and the South pole. In between the N and S pole, we have a plotting compass. It's always going to point in the direction of the force of the North Pole. Since the force is going like this, where is it going to point? Like this. So it should be pointing, let's see, needle perpendicular to end faces and pointing to S. Okay, there you go. And I think they want, what do they want? An arrow pointing to S. Do we need, if something's in the curly brackets, doesn't mean we have to write it? Oh, they didn't tell me. Okay, I guess it would obviously make sense to label them. What, question 7? Yeah, it would make sense to label the North Pole of the compass would be here. This would be south. Okay. Uh, Explain why the needle comes to rest in this position. We know that the compass needle points in the direction of the magnetic field, and since the force produced by the North Pole is in this direction, then it rests in this direction. Okay. So 7. Okay. The compass needle aligns with the field or points the direction of magnetic field. That's for 1 mark. And let's see the end pole of needle attracted to this. Oh, okay. Oh, okay. So this is all useless. Okay, we wouldn't get the full mark here. We should mention that the north. Obviously, that's why. By the way, this is the north and this is the south, because the south is gonna attract the north pole of the compass. So magnetic field, that's 1 mark. What I wrote, like what's written now is 1 mark. Then I have to add over here, and the north of the compass is attracted to the south of the magnet. Let's see. So the compass aligns with the direction of the magnetic field and it's attracted to the S of the magnet. That's a nice, easy 2 marks, right? Describe a method of demagnetizing a bar magnet. So in the marking scheme, we have 4 different methods. Uh, what you can choose whatever you want. Well, actually, no, it's 2 methods. This is one method, and this is another method. Okay, so heat or hammer, and you need the magnet lying on the floor, east to west. What does this mean? Yeah, okay. So the easiest one's obviously to smash it with the hammer when the magnet lying horizontally from east to west. Okay, so that's obviously the easiest one. Just smash it. Smash the magnet with a hammer with the magnet lying horizontally from east to west. Okay, I don't really understand this east to west, but I think they just mean in a, like, this is the east side, this is the west side. I'm not sure, but that's how it works. That's it for question 7. Now question 10. Okay, 10 over here. Figure 10.1 shows the potential difference current graph. So it's actually the IV graph, VI graph for a circuit component K. Calculate the resistance of component K when the current is 4 milliampere. Okay, R is equal to V over I, right? So at 4 amperes, we're going to get the value. At 4 amperes, the value is actually, let's see, it's 5 blanks, 2 divided by, so each one is 0.4. So 8.4, 8.8, 9.2. Okay, so this one's here is 9.2. How I calculate this one's division to be 0.4 is because it's 5 blanks and you have 2 as a difference. So 2 divided by 5 is 0.4. Okay, so it's going to be 9.2 over 0, oh, over, sorry, 4. Over 4. And you're gonna get, it should be, I don't know, actually, I'm not gonna bother. 9.2 divided by 4, and should be to two significant figures, 2.3 ohm. Okay, let's see. Question 10. Okay. See here, sorry. It's the same thing, but I didn't realize that they said milliampere. Okay, milliampere. Please pay attention to the units, guys, especially if you're doing externals. It would suck to get this wrong. Okay, the voltage is 9.2 and the current is 4 times 10 to the negative 3. Okay, so you're 2.3, so my answer should be 2300. Okay, if you divide these, it's like you can see 4 divided by 4 times 10 to the minus 3, 2300 ohm. You need to put the unit. Okay, and I guess, would you need significant figures? I guess if you want to play it safe, you could say 2.3 times 10 to the power of 3. Oh, okay. This would be accepted as well. That's it for 7. Oh, no, we have part B. Okay, sorry. Figure 10.2 shows a circuit containing component K. So this is component K. At low temperatures, component K has a much greater resistance than resistor R. And at high temperatures, component K has a much smaller resistance. State and explain the effect on the lamp when the temperature changes from very low to very high. Refer to the voltage at point X in your explanation. Obviously, when we're going to change from low to high. At low temperatures, there's high R. And then at high temperatures, there's low R. Okay, what happens to the bulb if there's less resistance? Of course, the bulb will brighten, right? And why would it brighten? Okay, obviously because when, or no, at high temperatures, you can say, well, okay, when the temperature increases, what's gonna happen? The resistance decreases, right? What happens when the resistance decreases? Thus, the current will increase. If you have less resistance, there's going to be more current flowing, right? So the current will increase. And to get the 4 marks, we got 1, 2, 3. To get our 4th mark, they said refer to the voltage at point X. What happens to the voltage? Obviously, voltage will increase as well. And then they said name component K. What is the component that has a VI graph where basically when temperature decreases, there's more resistance, but at high temperatures, less resistance? It's the NTC thermistor, right? So the NTC thermistor. You don't need to say NTC, I don't think. Yeah, you can just say thermistor. Okay. Before, this is wrong here. I didn't get the mark because I'm checking the marking scheme. You have to say the resistance of component K or the thermistor or whatever. Okay, the resistance of of K. You have to mention the resistance of what? Because we have resistor R and component K. Okay, so we have to mention. Okay, you have to say the resistance of, let's just say K over here. Like this, we're done question 7 and 10. Thank you so much for watching, and good luck.